Thank you to everyone who's joined. The webinar today will be on Microsoft's global secure access, in particular around the Entra Internet Access and Entra Private Access solutions. For you that don't know me, my name is Sam Jackson. I'm one of the solutions architects at Softworks. So today's agenda, we'll run through a little bit of the news, a couple of bits around global secure access and the releases within the product at the moment. And a couple of bits around licensing as well, a bit of housekeeping. We'll run through Microsoft's Global Secure Access in terms of the overview of the product, the topology of the networking, and also the licensing models as well that they've got currently available. We'll then move into the Microsoft Entra Private Access segment of the platform, in particular around the key features, topologies, and also the key scenarios where this could benefit your business as well. And then we'll jump into the Microsoft Entra Internet Access. And again, we'll look through the key features, key scenarios, topologies, and whether that can also benefit the business. And then lastly, we'll do some configuration examples as well. So around web content filtering, TLS inspection, and just really run through a very basic config of Entra Internet Access for you guys. And then obviously we have the Q&A at the end as well. So in terms of news, Microsoft's Entra Internet Access, one of the products within the Global Secure Access platform, has now been added to the Microsoft Business Premium and the Microsoft 365 E5 license. So this is just for Microsoft traffic, but is a really positive step in terms of Global Secure Access now that they're pushing this product into more of the business standard licensing SKUs such as Business Premium, the E5 license. Why this is good is because traditionally Global Secure Access was only available for either the Entra ID P1 and P2 SKUs or as standalone licenses, so either within the Entra Internet Access as a standalone, or Entra Private Access as a standalone, or the Entra Suite as well, which would have both the Entra Internet Access and Private Access. So a really good addition to both the Business Premium and the E5 license, just adding to the value that we already have within those licenses. TLS inspection has now been moved into preview for Global Secure Access. So we'll touch on a bit of TLS inspection later in the webinar. However, it's a massive improvement on the product. It was one of the elements that was letting Global Secure Access down, was the fact that we didn't have the ability to decrypt and then inspect and then re-encrypt network traffic, as ultimately 90% of traffic nowadays is always encrypted. So massive step forward in terms of TLS inspection, and we'll have a deeper dive into that as well. A couple of bits around licensing and funding from Microsoft. So the data and threat protection workshops for 300 plus organizations, if they qualify, is now being funded by Microsoft. So those workshops are really, really useful. It really surfaces a lot of the data and threat protection improvements the business could take, but also the positives and what the organization is already doing well in terms of data and threat protection as well. So we potentially could look at re-stratifying our cybersecurity plans if we already know that we're doing well in terms of our data classification, but we're not doing so well on our threat protection. It's a really, really good little workshop there if you do qualify, completely funded by Microsoft as well. The Microsoft 365 Business Premium grant and Office 365 E1 grant will be discontinued for non-profit customers upon next renewal from the 1st of July. So that's definitely one to have a conversation around with your account manager as well, to start planning for budgets and potentially readjusting the licensing SKUs as well. And lastly, we've got CSP licenses for 3 years or 5 years is available now as well. So again, building on the CSP licensing platforms as well that you've got with your existing licensing providers. So loads of really good news coming out from Microsoft at the moment, about 6 months into the year now. So no doubt coming into Q3 and 4 as well, we're going to have more and more news coming around, not just from Global Secure Access, but for licensing and other structures within Microsoft as well. So if we jump into an overview, so to start us off, we'll have a look at Global Secure Access as a whole and what actually is that. So Global Secure Access is actually made up of two core components, Microsoft Entra Internet Access and Microsoft Entra Private Access. Microsoft Entra Internet Access is the ability to provide ZTNA or Zero Trust Network Access controls to to and from your endpoint devices out into the world of SaaS and the internet, as well as your Microsoft 365 endpoints such as SharePoint, Office, Outlook, all of that good stuff. What Microsoft Entra Private Access does is really, really clever, and what it allows us to do is have dedicated tunnels to our on-premise infrastructures or our on-premise hosted applications. So rather than having a traditional VPN, having a tunnel into our virtual networks, to our on-premise firewalls, and then having access to that whole network, whether it be a VLAN or whether it be just a flat network, it allows us to provide more segmentation. So if you see on the bottom of this diagram, we've got three key areas. We've got identities, endpoints, and remote networks. The differences between global secure access is that global secure access is what we call identity aware and endpoint aware. A traditional VPN isn't necessarily aware of the user or the device that's actually connecting to that VPN. It's aware that there's been an authentication, whether it be certificate-based or a username and password, but it's not actually aware of who that user is and what they've got access to. Same with the endpoints. The VPN is not aware if that endpoint has a medium or high device risk score. Is it compliant? Is it enrolled? It's not aware to that level, and that causes a threat. You know, if the VPN is breached, someone gets control of that, then ultimately they've got a straight dedicated tunnel to the internal network. So global secure access is all built around that ZTNA platform. You'll see at the bottom there as well, we've got verify explicitly, use least privilege, and assume breach. So when we connect to global secure access through either the client connector or remote network, and we'll have a look at a little bit of that as well, we verify explicitly. We verify explicitly that that user has got access to global secure access. What have they got access to in terms of 365 and the internet? And verify explicitly that that endpoint has got a BitLocker encryption. It is compliant. And as well as that endpoint is not a risk. You know, has it had an antivirus scan? Has it had significant amount of PowerShell scripts being executed on it? We've then got the use least privilege, so only providing access for our endpoints and users to what they need. Similar how we would do it in Microsoft Azure. We wouldn't provide owner on the resource group. We would provide contribute, so you could build a VM, but we don't want you to have the ability to control the entire resource group. Same principle applies within the Zero Trust framework for global secure access. And then lastly, we've got assume breach. So we're always assuming that the identity of the user has been compromised or the device itself has had a breach or that's compromised. That also falls into your remote networks as well. So that tunnel between your firewalls through global secure access out into the worlds of the internet, IaaS, PaaS, and 365 as well. So if we dive a little bit deeper into private access to start with. So Entra Private Access allows users to connect to on-premise applications through dedicated tunnels and passes through what we call the Microsoft Security Service Edge, or otherwise known as the SSE solution. Now, the SSE solution is effectively Microsoft Network Edge, in which the dedicated tunnels will terminate at. And once they've been terminated, that's where all of the web content filtering, all of the TLS inspection, all of those ZTNA controls are based within that platform. That's all provided by Microsoft. So if we just look to the left-hand side of the screen, we'll see we've got our identities, endpoints, and remote networks. So what's happening here is our endpoints, as an example of remote networks, they're being provided a dedicated tunnel directly into the Microsoft Security Service Edge, and then back out for another dedicated tunnel to all of our private apps and resources. So whether that be a virtual network in Azure, or maybe we've got a application farm in AWS or Google Cloud, we can terminate there and have inspection through those tunnels. Or we may just be wanting to access corporate network services such as 3389 with RDP, SSH, SMB shares, FTP on 21, ERP applications, or any other web applications that the organization has. So it's really, really useful. And what we'll also touch on a little bit around private access as well, some of the key scenarios around how we can enforce single sign-on and conditional access around the client connectors and dedicated tunnels as well. One thing you will notice as well on that left-hand side where we've got dedicated tunnels, we've got conditional access in Microsoft Entra ID, and we've got continuous access evaluation. We'll touch on those in a little bit more detail, but just bearing in mind that at the point that a client or a user dials up to that dedicated tunnel, we've immediately got the ability to enforce conditional access and also evaluate the endpoint and evaluate the identity of that user as well. So we can begin to enforce MFA and things like that. So a couple of key features. So broad application support. So traditionally, as when this product first came around, we didn't have full support for RDP, SMB shares, and FTP and things like that. Now we've got any port and any protocol, so we can access non-web based applications. Again, let's use the example of the development environment. We could have an app segment that allows our dev team to have 3389 to our backend servers for patching, for example. We've got identity-centric security controls. So conditional access using the Microsoft Entra platform. We can revoke the authentication to the tunnel. We can enforce multi-factor authentication. And we can also enable single sign-on to private applications. Really, really useful if you have got a on-premise application or multiple on-premise applications. And they don't natively support single sign-ons. They don't have SAML, they don't have OAuth. Why this is useful, it means that ultimately you don't need to start redeveloping your product. You don't need to start redeveloping the database schemas and then go through that whole change management process and redeploying that. We can provide single sign-on to our staff to that service just by leveraging the Microsoft Security Service Edge or SSE. And then lastly, we've got segmented app access. Like I said, we may want to provide certain applications to certain users. For example, if we've got HR and finance, we may want to provide them access to Sage. You know, Sage Payroll, HR or accounts may need access to Sage Payroll. But for example, someone in the operations team may not need access to that, so we don't need to provide them access to that. And that's really good for things like Cyber Essentials and ISO, because we've got a clear boundary between what applications users or groups have got access to based off of their job roles and responsibilities within the business. And then lastly, we've got app discovery and onboarding. So we can discover more private apps, onboard them to segmented app access to the resources as well. If you've got legacy private applications that are still wandering around, maybe they've not been decommissioned fully, well, traditional VPNs, you're going to terminate on a virtual network. If it's a flat network and you've got 3 different applications, one of them's legacy, well, that VPN is still going to have access to that legacy application. So we can segment that off and then provide the onboarded solutions as well to our IT teams. Flexible deployments is a big one as well. So what we mean by flexible deployments is there's more than one way to deploy global secure access. So on the left-hand side, what you'll see is devices with SSE clients. Now, what this is effectively a client connector that is distributed to the device, which we'll have a little look at as well. And that effectively tunnels out your traffic to the Microsoft Security Service Edge, and then based off of the destination of that traffic, the web content filter, your TLS inspection, all of that good stuff within SSE will reach the destination where it needs to go, whether it be Microsoft traffic or internet traffic or SaaS-based applications. However, you can also expand this to your corporate network, so your SD-WAN solution or your firewalls, effectively having a site-to-site IPsec tunnel, which will provide routing out from your corporate network to the Microsoft Security Service Edge, so devices within the corporate network can still leverage the ZTNA properties within global secure access. Now, why that's really useful is if you've got a slightly legacy environment, maybe you've got a couple of kiosk machines, they are running Windows 11, but they need to be isolated, or we don't want them to have massive internet access to areas they don't need to, then it's really useful just to have that traffic going out from the firewall or the SD-WAN to the Microsoft Security Service Edge, so we can start to control where those kiosk machines can get to. If they need to get to a SaaS-based application or a hosted database within the cloud, we can isolate that and we can control the traffic to that. Another good example for that is printers and your IoT devices as well, being able to provide filtration on those devices as well, and inspection if needed as well. So flexible deployments, and this isn't Microsoft reinventing the wheel. Global secure access works in a very traditional way. Companies such as Zscaler and Netscope, they all work off the same model of effectively client connectors on endpoint devices, and then IPsec or GRE tunnels from your corporate environment, whether that be an SD-WAN or your firewalls as well. So tried and tested method. If it works, don't change it. Some of you may have noticed in the bottom right as well, a couple of bits around public preview and branch connectivity for internet traffic coming soon. As I said earlier, Microsoft's global secure access is moving and developing significantly quicker than it has been in the past. We haven't really heard too much around it in the past 12 months. So as we go through this webinar, I will make aware to you some of the key components that are either in public preview or private preview, just so you guys are aware as well. So just to kind of recap a couple of key scenarios here. Entra Private Access, replacing your legacy VPNs with zero trust network access. Like I said, traditional VPNs are not likely to support identity awareness and endpoint awareness. We don't have the ability to tunnel specific users to certain locations based off of the device risk score of an endpoint or the user risk score of the user. If the user's got a medium or high sign-in risk, then we should be able to enforce ZTNA and say, okay, we're going to block that user or trigger an MFA prompt. We're able to reduce the risk by enforcing adaptive conditional access. So like I said, with user risk scores and device risk scores, if a user becomes medium or high, maybe the device has gone to a medium, then we can control and block access to certain private applications. If a device risk score has gone to a high, we may want to block the access to all private applications and resources entirely. However, if it's gone to a medium or a low, we may just want to block access to maybe our SAGE system or our core business critical systems with GDPR sensitive data. That follows into the enforced adaptive multi-factor authentication. Same principle applies. Is the device at risk? Is the user at risk? Has there been anything changed within the environment that means that we would potentially want to trigger an MFA prompt? And then lastly, we've got fast and easy access at global scale. So at the moment, the Windows platform, Android has just come out of preview, but Windows and Android is now supported for global secure access. However, iOS and Mac is currently in preview. iOS is in private preview, so if you do want to get your hands on that, you do have to request the access to Microsoft. And then the Mac OS as well is now in preview as well, so you are able to get that, and that's not private. And then lastly, enabling the single sign-on, supporting your non-HTTP, HTTPS apps with single sign-on for legacy protocols like Kerberos. So if you do have those on-prem legacy style applications that don't support single sign-on, they don't support SAML or OAuth, or you don't have a web application firewall in the front of it to already hand over that authentication, then leverage the Global Secure Access platform. Use the Secure Service Edge as your point of handing over single sign-on authentication to those applications. So if we move into Entra Internet Access, it flows on quite nicely from the last diagram. So you'll see here with Entra Internet Access, it works in near enough the same way. On that left-hand side, we've still got the identity endpoints for remote networks. So again, we're still identity aware, and we're still aware of the risks and what the device the user is accessing it from is like. Does it have compliance? Is it BitBlocked? Same with the remote networks. We've got visibility of that remote network. We've got visibility of what's going on. Same principle applies to the Microsoft Security Service Edge, SSE. It will still channel that traffic through that platform, where at the point of connecting to the SSE solution, we will verify explicitly, we will use least privilege, and we will always assume breach. Really important that at the point of the connection to the SSE solution, we're always working off of zero trust, no matter what we're doing, what the device is, what the user is, whatever the remote network may be, whether it be the head office or a satellite site. We need to verify explicitly, use the least privilege, and assume breach at all times. Now, on that right-hand side, what you'll see is we've got Microsoft apps and all internet and SaaS-based applications. What we'll touch on a little bit later is traffic forwarding profiles. Now, what you can do within the Entra's Internet Access platform is you've actually got two traffic forwarding profiles. So you can actually handle your Microsoft traffic differently to how you would handle your internet traffic. We'll touch on that a little bit later, but just bear that one in mind. So a few key features within Entra's Internet Access. So again, we can extend the conditional access layers universally. I'm sure a lot of you are already using conditional access, and this just builds onto the conditional access layers that you've already got. So using that continuous access evaluation, which we'll touch on, user identity awareness, device awareness, all of that good stuff. Context aware web content filtering is a massive one. So allow or block web content, web categories, and fully qualified domain names and URLs. Now, for any of you that are familiar with the Defender for Endpoint license, Defender for Endpoint P1, you do have web content filtering within there that the Defender for Endpoint agent will handle. However, it is very limited, especially within the P1, that you are bound to the web categories and the websites that Microsoft has pre-populated those web categories. So you don't have the ability to block or allow fully qualified domain names if you really wanted to. So for example, if you were a organization that works with military defense systems, for example, well, if you were to block a web category called weapons, then chances are you're going to block everything that involves anything to do with weapons. But if you're got a military contract, you may need to go to a URL or a fully qualified domain name with multiple URLs that you need to access, so you can provide that deeper dive filtration on your web content filtering. Protect against internet threats. So this is a massive one. This is TLS inspection. So as I said earlier, 90% of internet traffic is encrypted nowadays. So if you can't inspect that traffic, then there's minimal use towards inspecting traffic, because you're only going to get 10% of it. We'll touch on TLS inspection in a bit more detail, but I know for a couple of people that are actually listening to this, one of the reasons why they hadn't taken up global secure access yet was because they couldn't use TLS inspection. They couldn't see what 90% of their traffic was doing in the realms of the internet. And as we all know, the internet is a dangerous place where it needs to be. Entra ID integrations. So we've got a whole separate slide on this, but preventing token replay attacks by extending the compliant network across CA. I'll explain this in a little bit more detail, but what this effectively means is you can restrict access to your discovered applications or 365. You can restrict access to a compliant network, and you can set your global secure access, so your SSE solution, the security service edge, as the trusted network location. So effectively, whether you're in the office, whether you're in a or you're in Costa Coffee, Starbucks, wherever you may be, you can only ever get to your 365 environment, your SaaS applications, your on-prem environment, if you come from that security service edge client, which has been deployed from your tenant and your tenant only. We'll touch on that in a little bit more detail. However, that also helps protect against the data exfiltration as well, and also restoring original end user source IP, which again, we've got a separate slide on, and ultimately improving end user experience. So we all know Microsoft Backbone. If any of you ever deployed a virtual machine in Azure and done a speed test, the internet speeds are out of this world, and we know that they're robust, we know they're resilient. So improving that end user experience, rather than dial into our firewall, maybe we would have a network issue on site, maybe we've had a power outage, or maybe the firewall's just going through patching, or anything like that. Going through Microsoft's global network is going to give you that global scale and the backbone of that as well. So continuous access evaluation. So what this is effectively when a client or a user or remote network is connecting to the security service edge, because this is based off of Entra, we get massive amounts of information through different signals within the Entra solution. So on that left-hand side, what you'll see is we've got identity, workflows, groups, and roles. So we can identify certain individuals, certain groups, certain roles, and their access to the security service edge and ultimately the destination. We're also looking at the risk signals, like we mentioned, the device risk score, user risk scores, risky user sign-ins. We can look at the trusted and compliant devices. So is the device enrolled in Intune? Does it have BitLocker? Does it have Defender? Does it have an antivirus scan in the last 24 hours? We can have a look at the apps and data. We can also have a look at the location, where's it coming from, and also the compliant network. So what's really, really clever within the whole ZTNA solution of the security service edge is if any of these signals flag up as there's a potential risk or I'm not too sure about this, we've got the ability, as you see on the right hand side, to either allow, require MFA, block access, or enforce a network security control by blocking access to a certain SaaS-based application or your Microsoft 365 applications. So the continuous access evaluation is effectively just looking at your endpoints, looking at your users and identifying, is there any risks? And if there is a risk, what do we want to do about it? If you do need to block access, that happens in real time. So if there is a high risk, the tunnel will immediately drop, the token will be revoked, and the user won't be able to get access. There is no, 2, 3, 4, 5 minute delay. It's near enough real time. So it's really, really useful. Obviously, if you've got the likes of Sentinel, you get really useful logs out of this as well. So you can begin to maybe look a little bit more deeper into what user risk scores are going on, and has there been any blocks on the tunnels, token revokes, and everything like that as well. Really, really useful. So source IP traffic. So source IP traffic, we'll run through the slide and we'll explain it a little bit more. So source IP traffic is the ability to restore source IP context for all Microsoft Entra ID risk assessments, so user risk and sign-in, user sign-in risks. This is useful because within the Microsoft Entra ID user risk, sign-in risk, the activity logs, audit logs, wherever there's an IP address of a connection, it's significantly easier to understand the risk of that connection and what's happened within that connection if we retain the source IP. So for example, if you're dialing up through to a traditional VPN, you're coming in from your home network, you tunnel into the firewall, and then you're given a secondary IP address. Well, at that point in time, we've got two IP addresses in play. We've got the source IP and we've got the VPN tunnel, the VPN client tunnel that's been distributed the IP address within that VPN segment of the network. So at that point, we can't really determine what's going on in terms of Entra because the user and device is already sitting on a different IP address. Effectively, Entra is now looking at two different IP addresses, and we can't juggle the two. So by retaining the source IP traffics, we get what we call backwards compatibility. So we can use that backwards compatibility. We can use that source IP address to understand the user device risk score, the Entra ID risk, the activity logs. We can leverage the use of compliant networks within our conditional access to only allow access to 365 through the compliant network. So retaining that source IP traffic is really, really good. You may have heard other platforms call it source IP anchoring. Same scenario here, retaining source IP, anchoring that source IP so we can get the information we need out of it, and ultimately monitor and control that network connectivity through the SSE solution. Token theft protection. So I'm sure everyone here is aware of token theft protection. It's becoming more and more common as more organizations adopt single sign-on, as more organizations build and develop their estate, as more applications move to SaaS. A primary refresh token or a PRT or even a secondary token, it's like gold dust. You take someone's token, you've got the keys to the chamber, unless you've got controls in place to minimize those. You can see there just a couple of statistics as well. So 4,000 identity attacks blocked per second, 42% successful identity attacks, the distribution of the top 4 attacks, so identity attacks, ransomware, targeted phishing, and business email compromise, and 100% increase of token replay attacks year over year. So it's a massive growth, as I said, as more applications move to SaaS, more organizations take up single sign-on. So always leveraging the primary refresh token. So how can global secure access or Entra internet access help with this? So the first point there is, well, because I'm leveraging the use of the source IP, I may have a compliant network configured, like I mentioned. If I've got my 365 applications, my 365 environment, my SaaS-based applications, if that's restricted to only the Microsoft Security Service Edge within my tenant, Joe Blogs could take my token, but unless they're on that compliant network tunneling through the security service edge, they can't come in. So we warrant the use of that token useless. because they're not on the network level of authentication. Traditionally, if that token was taken and there was no blocks in place around the corporate, if there was no blocks in place, sorry, around the access to 365, they'd be able to access Azure portals. If there's no controls in CA around that, they'd be able to access Outlook, 365, SharePoint sites. And then we get into the, we've got a breach. How far have they got? Have they made any app registrations? Have they got into additional mailboxes? So we can instantly revoke those stolen access tokens as well. So again, this will leverage the use of risky user sign-ins or risky users. Say, for example, someone has tried to sign in from 4 different locations. Well, that risk is going to then affect that user's identity, because I've tried to sign in from 4 different locations. It's been a bot attack, and we can revoke the session on that user account as well within that device automatically. So we can take that user away and say, okay, you've got a breach, we've isolated your device through the global secure access controls, and now we need to look at mitigating the breach that we've potentially had. This will extend as well to your federated cloud applications as well. So whether it be your browser or it be client access, as long as you've got the single sign-on there and you've got your global secure access configured correctly, token theft protection is really, really useful, and definitely something everyone should look at doing if they do take up global secure access. So a couple of key scenarios is the context-aware web content filtering. So the ability to filter out web categories, allow certain web categories, but also the ability to filter out certain fully qualified domain names, FQDNs, and also allow specific FQDNs as well. The adaptive policy decision. So again, creating adaptive web content filtering policies that only apply when a risk level happens. So the user has now become a high risk. We're now going to implement adaptive web content filtering, so they can no longer get to Sage, they can no longer get to 365, SharePoint, for example. Governed access to business restricted sites, again, goes back to Sage, restricting the access to certain sites. If you've got anything in the browser, restricting the access to that based off the risk scores. And then lastly, just touching back on that, token replay attacks, warranting the primary refresh token useless unless you're coming through this Microsoft security service edge that's been distributed from my environment. Excellent. So just a bit of a overview really of the client connector deployments and the traditional deployment of Entra Private Access. So really, really simple to deploy the client connector. It's an exe download that you can get from the portal. As you'll see on the screen, Windows 10 and 11 and Android are in GA, general availability. Mac OS is in preview and iOS is in private preview. Deploying the client connector could be done through Intune or any other app distribution software that you use. So Managed Engine or any other form of MDM that does your application distribution can be used in there. The Global Secure Access client will use the authenticated user account to seamlessly sign that user in as well. So again, it uses that primary refresh token, the Entra ID account used to authenticate that token, and it will seamlessly sign it in. And you can see there just an example of my machine connected up there. I've got internet connected, I've got Entra, and I've got Microsoft 365 tunnels connected with my client version as well. So really, really simple to deploy. Microsoft guides are actually quite good on this as well. So if you know how to distribute applications, EXEs using the Intune Win tool and command line installs, you'll be completely fine. But if you need any help with that, by all means, let us know and we'll help you through that. So as I mentioned earlier, there's traffic forwarding profiles. So there's 3 different traffic forwarding profiles. So once you've got that client connector set up and pushed out to all devices, it'll be seamlessly signed in, but it'll be set to disconnect by default because there's no traffic forwarding profiles assigned and there's no conditional access policies enforcing the security profiles. So out of the box, you've got your Microsoft trafficking profile, and you've got your internet access trafficking profile as well. So trafficking the network traffic out differently. So your Microsoft traffic profile, what you'll see there is it applies to the internet traffic to Microsoft services. You've got 4 different Microsoft policies, which we'll just show as well. And then you'll link conditional access policies. So We'll touch on this as well. However, conditional access is what we use to enforce the policies. And you can see there in the lab, I've got 15 different ones all referencing this policy. And then lastly, you can see the user and group assignments and also the remote network assignments to that policy as well. You've got your private access profile as well, self-explanatory. This is your private access profile that you want to distribute to users who need access to certain on-premise applications. Again, whether that be Sage, whether that be a on-prem legacy application that you host yourself, doesn't need to be an external application at all. And then lastly, your internet access profile. So this will be all internet traffic, excluding your Microsoft traffic profile. And that follows the same logic of conditional access with user assignments and remote network assignments as well. So the reason why we've got two different Entra internet access profiles, you've got the Microsoft and you've got the internet. As I said before, we may want to handle this traffic differently. The Microsoft traffic, as you'll see here, the Microsoft traffic is already predefined. So Exchange Online, SharePoint, common Office applications such as Word, Excel, your OneDrives, your PowerPoints, all of that's predefined. So you have your fully qualified domain names, you have your IP subnets and your ports there as well. So that's already predefined, and with Microsoft maintaining their FQDNs, then maintaining the IP subnets and ultimately their backend security, you may find that you want to bypass that traffic, or by all means for the traffic, but you may find that we don't need to inspect the traffic going to here. We're happy to accept the traffic coming from the Microsoft Security Edge is happy to be forwarded on. Now, one of the big limitations currently, and you may have noticed on the right hand side where we've got protocols and we've got actions. So within either the Microsoft Internet Access or Microsoft Traffic Profile or the Internet Access Profile, you'll be able to forward and bypass certain traffic. Now, as of current, UDP traffic is not supported. So you do have to bypass UDP traffic at this point in time within Global Secure Access. However, TCP traffic, you can forward all your TCP traffic through the Security Service Edge for web content filtering and also TLS inspection as well. So a limitation, yes, not the end of the world. However, it is something that I know Microsoft are working on to get it deployed. It's a massive one. UDP is needed for Teams, your Azure virtual desktops and things like that. So obviously your Azure virtual desktops, for example, are going to want to be inspected with UDP. It's usually got quite a lot of sensitive information on your AVDs, your Sage clients and things like that. So just one thing to bear in mind, that if you do want to roll out Global Secure Access in terms of the internet access filtering, then you will need to bypass UDP traffic at this stage. However, if you want to set up your web content filtering, so let's say, for example, we have used the default Microsoft Internet profile and assigned that to our users, and we've got the client connector out. However, we want to create a web content filter for all staff. So really, really simple to do. You create a web content filtering policy, you give it a name, and you can give it a block or allow. So you can begin to filter out and exclude certain allows and blocks like you would with a conditional access policy. Once you've created the basic setup for that, you can add the rules. So give it a easily identifiable name, block gambling, and then you can see there we've got the destination type. So web category, you can block all gambling web category sites that Microsoft are aware of, or you can use FQDN. So you could do a block on the web categories, and then you could do a allow on the fully qualified domain name. For example, if you worked for a betting company and you needed to go to the front page because you worked in the marketing team and wanted to see what the website was looking like. So you have got the ability to do that in more granularity than you do within products such as Defender for Endpoint. So security profile. So once you've created a web content filter policy or a TLS inspection policy, you'll need to create a security profile. Now, effectively what a security profile is just a profile that contains various different policies that can be assigned to a subset of users or an individual user. So on the screen here, you can see that I've created a security profile, in particular focused around blocking gambling for all users. You can see that I've got the state, enabled, disabled, and I've got a priority as well. So for you that are familiar with NSGs in Azure and the priority rules of those, or maybe an exchange online with the mail flow rules, you can set the priority. So you can say, my default policy is block gambling for all users. However, policy 101 is a default catch-all for everything else. So you've got the ability to build priorities into your security profiles based off of what linked policies you've got within them. So on the right hand side, you can see there, as part of this security profile, I can either create a new web filtering policy, or I can add an existing web filtering policy or an existing TLS inspection policy. In this case, I will use the recently created web content filter policy for the blocking gambling. So just to quickly follow on from security profiles as well, what you'll see at the top there is you've got both security profiles and baseline profiles. So your security profiles, as we went through, they're your custom profiles that you may want to assign certain security profiles to certain users. Good example of this actually is if you've got a development team and they need to access products like Docker. You'll want to bypass TLS inspection for Docker because it can cause issues with certificate pinning and things like that. So you may want a security profile handled for TLS inspection dev users, which bypasses TLS inspection for Docker endpoints and repositories. However, your baseline profile is effectively your default catch-all if you don't have a security profile. So that baseline profile is effectively assigned to anyone who does not have a security profile. So if, for example, I've got security profiles assigned to all users by a dynamic group, for whatever reason my syntax was wrong with that dynamic group, maybe it was looking at a license SKU that this user doesn't have, then that user would still be bound to your baseline profile. And then typically your baseline profile will be allow all websites, but filter out your web categories and filter out the destinations that you don't want them to get to, and obviously you'll want to review what users have beside a baseline profile as well. So once you've got your security profiles assigned, you've got your web content filtering in there, you've got your security profile assigned, you've decided what users and groups you want it to go to, you split out your Microsoft traffic, you've decided your internet access destinations, you can then begin to build out your TLS inspection. So TLS inspection works in near enough the exact same way to creating a web content filter. So you go into your security profiles, your TLS inspection, give it an easily identified name, and then you'll see on the action there we've got bypass and inspect. So for your typical traffic, your TLS traffic, your encrypted traffic, you're going to want to inspect that. So you're going to want to set that action to inspect. However, like I said, if the dev team use something like Docker, or you need to bypass TLS inspection for whatever reason, then you can have a TLS inspection policy, which is assigned to certain destinations as well if you do need to. Now, the big difference here is that in order to configure TLS inspection, you will require a PKI infrastructure for a signed certificate. Now, the reason for this is because effectively the way that TLS inspection works is there's an intermediary certificate which is used for what we call certificate pinning, and effectively that's a trusted certificate that is distributed to the clients, which is used to decrypt the TLS encrypted traffic. So your HTTPS TLS encryptions, decrypt it using the certificate, inspect it, and then re-encrypt it and allow it to hit the endpoints browser. Relatively simple to do. If you've got the PKI infrastructure, you can generate the CSR, get that into your PKI infrastructure, and then get the signed certificate as well. And I do believe there's logging as well for the expiry date of that as well, if you wanted to have that going into your service desk. So lastly is your policy enforcement. So if we just really quickly recap, you've got your web content filtering. You may, let's just say you're bypassing your Microsoft internet traffic. You've got your internet access policy set up. You've got your web content filtering policy set up. You've got your TLS inspection and bypasses set up. Well, we now need to enforce these policies, and that's all done through conditional access. So really simple to do, follows the same logic of conditional access, your if, else, and then statements. You know, do this, don't do that, have a look at this. And you can see here, just a quick example, I've got is that blocked category that I just made earlier. So global secure access blocked category for the gambling. I've assigned that to my user, my Windows device, with the conditions that I need to use the global secure access security profile block gambling for all users. So it's pulled that security profile through that we've just collected. So within that profile there, block gambling all users, I've got TLS inspection and I've got web content filtering on gambling websites. So you can enforce that, you can do exclusions. A really cool little tip as well is you can enforce Defender for Cloud apps as well. So if a user isn't using global secure access, you can enforce Defender for Cloud app access app control within there as well, and enforce restrictions as well. So here, just to give you a bit of an oversight of how it kind of looks within the traffic log. So you can see here, my device, sam.jackson. You can see there the fully qualified domain name, bet365.com, the actions block. And you can see there that I've had 148 connections. 125 of those connections have been to a internet endpoint, and 23 of those 365 access has been a Microsoft IP subnet or fully qualified domain name. Now, what you will notice is the block notifications isn't massively pretty. That is something that I have a call in a couple of weeks with Microsoft that I'm going to raise up there as well. Is there going to be custom block notifications? Because ultimately, if I was an end user and I tried to get to a web page, maybe it wasn't gambling, maybe it was an internal application, and I got hit with this connection was reset, I would likely raise a ticket to support and say, I think I've got a problem with my internet. So that is something that needs a bit of improvement, is just a bit more information for the user to say you can't reach this page because it has been blocked by global secure access, bit of branding, bit of company branding, so you know that it's actually a true site as well. So an improvement that needs to be made there for sure, but ultimately that's how it works. So lastly, licensing. So the licensing model is interesting. So you've got your Entra ID P1 and P2. That will include your Microsoft traffic. You can get your standalone internet access, and you can get your standalone private access. Will give you fully fledged access to all of the controls within internet access and private access. Or you can get the Entra suite, which will include both your internet access and private access, fully fledged suites within there as well. Like I said, Business Premium will now have Microsoft traffic. As you can see there, it includes Entra ID P1 on that left hand side. So you can see that when we get that source IP restoration. Great, we can tie down our 365 endpoints. We've got the Windows client, we've got the Mac OS client in there, compliant network check. So there's loads that we can do within there. If it's already included in the license, good idea to run a bit of a POC. You may find that it's really well adopted and that you actually want to go and see what the cost will be from your licensing provider. I believe retail RRP is around $5 and the suite goes up to around $9 as well. So yeah, excellent. Phoebe, I guess I'll hand it back to you if there's any questions floating about. Faith, whoever.
Yes, we've had a few come through. The first one I can see is, do we know when UDP inspection will be released?
UDP inspection, I would imagine, will be released within this year, within the next 6 months, I would like to think. UDP inspection is one of those things that Microsoft haven't been too vocal about in terms of kind of the insider programs and things like that, but it's something that we're definitely going to ask in a couple of weeks' time as well.
Another one is, can you configure custom block notifications?
Hopefully soon. Obviously, as I mentioned, you can't at the moment. But yeah, hopefully it most definitely would likely come into play very soon.
Does the device need to be joined to Entra ID?
The device will require Entra ID. It doesn't need to be solely joined to Entra ID, but it will require at least hybrid join. So the authentication process and all of that within Global Secure Access needs that primary refresh token. So it needs hybridization or fully joined Entra ID.
Another one is, you mentioned secure internet access to Microsoft is included with Business Premium. Is that correct? Is this just to OneDrive, SharePoint, etc.? How long does it take to implement?
Yeah, so the Microsoft traffic, so the Business Premium, it will, when you go to deploy it, it will just be that Microsoft trafficking profile that you'll have access to. So it'll be all of those Microsoft endpoints, Exchange Online, SharePoint, OneDrive, any predefined, fully qualified domain name or IP subnet. In terms of deployment, it depends how far you'd like to go with the deployment. But if you wanted to roll that out as a POC, I'd say you'd probably get it done in, well, depends if it's pro services, probably a couple of days. But yeah, POC, roll the client out, set up your Microsoft trafficking profiles. You can probably get a good POC set up and running within a couple of days.
Can we use this to replace Cisco Umbrella or not mature enough yet?
Not mature enough yet. I would most definitely say watch this space. Cisco Umbrella is good, but Global Secure Access, I would like to think within the next 6 to 12 months, I would probably quite comfortably say can replace it. But right at this moment in time, I wouldn't say so. Definitely proof of concept kind of area at the moment. Or if you don't have anything like Cisco Umbrella, if you don't have Zscaler, if you don't have Netscope or anything like that, definitely worth at least running an internal proof of concept or rolling it out internally for Microsoft traffic.
And finally, Will asks, Entra Private Access, how much of a blocker do core business apps represent that are currently using Entra domain services for businesses that don't have any domain controllers and looking to make a pivot away from AVD?
Yeah, so there's not massive blockers on that at the moment, to be fair. With the use of Microsoft, are always trying to push everyone away from the domain controllers. They want everyone to pick up the Entra domain services. As far as I'm aware, there's no real blockers in terms of that at all. So yeah, it's definitely something we can explore is leveraging the use of the Entra domain services and Entra authentications for single sign-on to those applications.
Thank you. I think that's everything I can see so far.
Excellent. As always, if there's anything else anyone would like to know more about, then please do reach out. Always do kind of one-to-one workshops if you've got any on-premise services applications that you'd like us to maybe jump into a little bit more, set up the single sign-on, get conditional access sorted out. By all means, let us know. Thank you, guys, and I think that'll be that.